Welcome to this recording on simplifying radical expressions. So we're going to start here with the square root of 80, and we want to write this so that the smallest number possible is inside the radical or the square root side. So what we're going to do is we want to find perfect squares, which are square root 4, square root 9, square root 16, square root 36, etc., etc. These are nice numbers because the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and square root of 36 is 6. Forgot one, didn't I? Whoops. Let's throw that one in there. I missed the square root of 25, which is 5. Okay, so looking at 80, let's see if we can break up 80 so that we get one of these perfect squares in it. Well, I can see that 80 can be broken up into 4 times 20. And so I can rewrite this as the square root of 4 times the square root of 20. And now we have the square root of 4, that's just 2. So 2 square root 20. Well, 20 can be broken up as well to be 2 times the square root of 4 times 5. And so we have 2 square root 4 times the square root of 5. And the square root of 4 is just 2. 2 times 2 times the square root of 5. Or we could just say 4 square root 5. Just like that. Now that's kind of a hard process and a little bit difficult to know, well, what do I break up 80 into so I can get these nice numbers out, namely 4 and later on this other 4. It'd be nice if there was an easier process that we could do. A little bit simpler, and that's what we're going to look into right now. What I'm going to do is I'm going to move these to the side. I'm going to show you another process you can do in solving these using the factor tree of 80. So let's write this. We have square root of 80. So the square root of 80, let's break it up into its factors. So we have 8 and 10. 8 times 10. You can pick any numbers, 2 and 40, whatever. This will work for no matter what you do. So let's break up 8 into 4 and 2. And we'll break up 10 into 2 and 5. And we're going to break up 4 into 2 and 2. So I now have the lowest amount of, or my factor tree completely factored out. And I'm going to look for pairs because when I pulled out the 4, it was just a pair of 2 times 2. So if I circle all of the pairs that I have in here, and that's all the pairs I have, this poor little lonely 5 doesn't have any pairs that you can combine with. And I can pull out one of these numbers outside of the square root. So that means I'm going to have 1, 2 from this guy times 1, 2 from this guy. And then I have the radical sign, and then whatever was left over, which was namely the 5. So this we have 4 square root of 5. So you can pick whichever way you want to do this. Personally, I prefer the green method, factor trees, because it's a little bit easier and a little quicker to work with. So that's how I'm going to do the rest of the examples on this. So this was problem number 2 if you're keeping track on the assignment. And now we're going to move on to problem number 8. Okay, this one's a little more difficult because we have more than just a number inside of there. We have 2 different variables. So we're going to treat these just as if they are, we're going to treat them independently. I'll show you how we deal with the variables in a second. So the 32 can be broken up into 2 and 16. And you may already recognize, well, 16 is a perfect square. And you're right, because we can break it up into 4 and 4. And you can keep breaking it up into 2's if you want. Or you can recognize that I already have a pair here, so I'm going to stop. I'm going to circle them. And we're going to take, I can rewrite this so the 4 comes out. And I still have the square root 2 on the inside. But what about this x to the 4th? Well, let's break that up into its factors. We have x and x and x and x, right? Because x to the 4th is just x times x times x times x. So just doing the same thing I did with the 4, where I look for pairs. Circle the pairs, circle the pair, and now I can take and pull out 1x and 2x's. So there's my first x, and there's my second x. And I have this y right here. He doesn't factor into anything besides, well, just y. So he can't come out of the square root. He doesn't have any pairs that I can circle him with. So he stays inside the square root. So I'm going to rewrite this because 4x, or x times x is just x squared, so it's 4x squared. And the radical sign, 2y. Okay? So there is that example on how to do that one.
Please move your cars now or you will get...
Sorry about that. Sometimes you don't know when the intercom's going to come on during a recording. So moving on to the next problem. This one's not in your assignment, but it exemplifies a point that we need to know for the next problem that we're going to do on the assignment. So you may notice that this one looks a little bit differently. Namely, there is now this 3 over here in the problem. Right there. We have a 3 right there. What this is saying, this 3, is that in order to bring anything outside the square root, or to take the cubed root, I need to find the number that when I multiply it by itself, 3 times I get this number. For example, the cubed root of 27 is equal to 3 because 3 times 3 times 3 is equal to 27. You can see that because that's 9, and 9 times 3 is 27. Okay? Not 25. 27. There we go. Alright, so instead of looking for pairs now, I'm actually going to be looking for triples. Triples that I can pull out of the sky. So here, with 8, still do a factor tree on it. We're going to get 4 and 2. And then divide this up, we're going to get 2 and 2. So here, I'm looking for combinations of 3, not just 2. So here's my combination of 3. So that means I get to pull out 1, 2 outside of the square root. And this p to the 5th, well, he's going to give us lots of p's. Let's change this color so it's easier to see this. Green for Copper Hills. Okay, 1p, 2p's, 3p's, 4p's, 5p's. So how many combinations of 3 do I have? Well, circle these 3 right here. So that can come outside of the cubed root. And that's it, because I have 2, I don't have 3. So those 2 can't come outside. So we write this as the cubed root of p, and since there are 2 of them, it's squared, p squared. Okay? Cubed root of p squared is still left there. So we have 2p cubed root p squared. And that's it. Now we are ready for the big boys. Okay, this one is the biggest one that we're going to do, and the last problem on this video. So, looking at it, let's start working with the 54 first. So we have 54 breaks up into 6 and 9. And you may recognize that 9 is a perfect square, and yes it is, because we get 3 and 3 out of it, so we can circle those two. And here we get 2 and 3. And it looks like we're not going to have anything that's going to combine with either of those. So let's write over here what I have that's coming out so far. This 10 over here, this one, just stays where it's at. We're going to do 10, and then we're going to pull out our times 2, and then times the 3. Okay? And so those guys came out. It seems that I made a mistake here, didn't I? It's not the 2 and the 3 that gets brought out of the square root, right? What gets brought out of the square root is just this 3 over here. So let me rewrite that. So it's going to be 10 times 3. And then left inside the square root, or in this case it's the cube root, left inside the cubed root so far is a 2 times 3, because the 2 and the 3 didn't have any pairs. Well, let's look at these other ones that are a little bit more long. So we have u, and we have 8 u's. 1, 2, 3, 4, 5, 6, 7, 8. It's a lot. I'm not going to write those all out because it's going to be a lot of work. Can you just believe me that if I circle pairs, now I better write them out. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 u's. I'm going to erase this over here. And I have 3 v's. Now I'm looking for pairs of 3 to bring out. So I'll take care of the v's first because that's pretty easy. I get 1 v that comes out. And then looking at the u's, if I circle pairs of 3, those 3 and those 3, that means I get 2 of them that come out. U times u. But I'm left with 2 u's that are left on the inside. They're sad, they don't get to come out. So it's times u times u. And so let's clean this up using squares. I'm going to do it all in black. So we get 10 times 3, and that's 30. Then we have times v, and u times u is u squared. You don't have to write those dots in between them, by the way. And then this is the cubed root of 6 times u squared. Okay? And that's it. If you have any questions, let me know.